Hi all, we're going to be talking today a little bit about conservation of mass. Remember that every type of atom and every single atom that goes into a chemical reaction must come out. And what makes the change during a chemical reaction is what atoms are connected to what and the properties of the compounds that are being formed. So what I want to do is just a classic demonstration of conservation of mass, and I'm hoping you can see my balance here. My balance, I want to zero it out. I just kind of threw it off when I lifted it up. And I'm going to put a beaker of vinegar and a tiny beaker of baking soda on top of my balance, my electronic balance. And one of the things that you need to recognize is that the mass is 132.1. So I want to show that to you. And I'm going to go ahead and add my baking soda to my vinegar. And again, the mass is 132.1 grams. So I'm going to add, and I'm kind of making a mess all over the place, but I want you to notice what happens to the mass. So it was 132.1, and now it's 124.4. Well, we said that matter is never created or destroyed. So I'd like you to be thinking about what potentially happened during this reaction, because it would appear that we lost mass. All right, now we're still talking about conservation of mass, but I have a different setup here. I have a glass vial with vinegar in it, and then I dump some baking soda into this balloon. And my setup is a little bit different than last time, and I want to see what happens with the same reaction having baking soda and vinegar. So look at the initial, let's see if we can get it in range here. The initial mass is 150.4. And now I'm going to go ahead and run this reaction by allowing the baking soda to dump into the vinegar. And I'm hoping that you're going to keep an eye on the mass. All right, reaction said and done. The mass of the products is 150.4. So that seems to uphold our law of conservation of mass.